Hello, so today we'll be doing lesson 5.6 where we will be connecting slope, variation, and first differences. So a relation can be represented in a variety of ways so that it can be looked at from different points of view. A mathematical relation can be described in one of four ways using words, a diagram or a graph, using numbers, or an equation. All this to say is that we want to be able to represent our mathematical findings in a way that is easy to understand and interpret. So we move on to our first example. This one is that a graph shows the relationship between the volume of gasoline in a car's fuel tank and the distance driven. We want to calculate the slope. What is this as a rate of change and what does it mean? So we use our slope equation, which is difference of y divided by difference of x, or delta y over delta x. And we just pick two random points on the line. So we have 0.65 as our x1, y1, and 239 as our x2, y2, respectively. So we plug in our values into our equation, and we get a slope of negative 13 over 100. So now that we have a slope, what does this mean for us? How can we interpret this result? So, as a rate of change, this means that we are consuming 0.13 liters per kilometer. Okay, so if volume, which is however many liters we have in the tank, if this is however many liters we have in the tank, then our line represents however many liters we have after driving a certain distance. And so we see that after around 500 kilometers, we'll have no more fuel in the tank. So that means that for every 100 kilometers driven, as you can see, 100, 200, 300, 400, we will use 13 liters of gasoline, and that's why it's downward sloping. Now we want to determine the y-intercept. So if you remember, the y-intercept is the y value when x equals 0. We want to know what does this number represent. So as you can see, at x equals 0 over here, we have a y-intercept of 65 or 0.65. So what does this number represent? We see that this means that the car initially had 65 liters of fuel in the tank at the beginning of the road trip. So this is however much liters are left in the tank. Write an equation for this relation. Is it a direct or partial variation? Well, we saw that the y-intercept was not 0, so right away we can see that this is going to be a partial variation. So first we define our variables like we always do. We let V represent the volume of fuel remaining in liters, and we let D represent the distance driven in kilometers. Therefore, we have this equation where we have our slope and our y-intercept. Now, we notice that our y-intercept is not 0, so since b is not 0, then this is a partial variation. You're driving to a friend's house who lives 44 kilometers from your house. Assuming you started with the original 65 liters of gas, how much gas will be remaining upon arrival at your friend's house? So, we let the distance be 44 kilometers because that's how far we're going to drive. And then we use our equation that we found for however much gasoline remains in the fuel tank. So we substitute our 44 kilometers into the equation. And then once we solve this equation, it should give us the amount of fuel that remains in the tank. So we compute. As you can see, we have all this happening, and then we have 65 minus this thing. So as you can tell, we got negative 572 over 100 plus 65. That gives us negative 5.72 plus 65. And then we just rearrange the equation so that it gives us 65 minus 572. And this gives us a remaining fuel tank of 59.29 liters. So there will be 59.28 liters of gasoline left in the tank upon arrival. Now we wanna compute for slope and constant of variation. A scientist researched levels of motivation in relation to hours of sleep. They were able to determine that patients who slept less also had less motivation to eat, work, or participate in any activities. They were able to model the relationship with the equation y equals 5x plus 10. Now we want to make a table of values and graph this relation. So we begin. Let x be our hours of sleep and let y be our level of motivation in vibes. So we just plot our x, 1, 2, 3, 4, 5, and then our level of motivation over here. So we can now plot this. We just plug in the values. We start with 0, 10 over here, and then we go from there. Every hour of sleep, we add 5 levels of motivation. So, using the graph, how many hours of sleep would a person need to get to reach a motivation level of 50 vibes? So remember that we were calculating a level of motivation in terms of vibes. So, y equals 50 in this case. And then, as you can see, once we go to 50 on the line, that means that we have 8 hours of sleep. So, using the graph, we can see this, that y equals 50 when x equals 8. So, in order to reach a motivation level of 50 vibes, a person would need 8 hours of sleep. Now, we have the slope and the equation of a relation. The question reads, Jackie earns $25 per day plus $9 per 100 flyers, for delivering advertising flyers. Now keep in mind that this is an example of using words to describe a relation. Okay? Now, 25 per day, that would be our fixed cost, and the relation and the plus $9 per 100 flyers, that would be our variable cost. That's why they are highlighted. The relation can also be described in other ways. So, using numbers, we want to create a table showing Jackie's daily earnings for various numbers of flyers. So, let's think of this. If Jackie doesn't sell any flyers, she'll make $25 because she earns $25 per day. Now, the flyers that she does sell, that is added onto her original salary of $25 a day. So she'll make $9 for every 100 flyers that she does sell. So our slope, or our m, or our constant of variation, would be 9 over 100, or in this case, 9 over 100, that's $0.09 per flyer sold on average. Now, since this value is of little to no use to us, because we're calculating $9 per 100 flyers, we will multiply this by 100 so that we can convert it to $9 per 100 flyers. And now, this $9 per 100 flyers, we can better use this. So, we can now make our table. We go from 0, and we start at 25, and then 100, 200, 300, 400, 500. And then we see that each time we add 100 flyers sold, her earnings go up by $9, like this. So we want to graph this relation. So I graphed it right here, and as you can tell that we start at $25, and then every $100 we add an additional $9 to her salary. Okay, so at 5, yeah, it's perfect. And then using our equation of, y equals mx plus b, we can now state, okay, so if E is our earnings and F is the number of flyers sold, then we can have that our relation is E equals 9 over 100 flyers per 20 plus 25. Our example now follows a local theater that is hosting 2 musicals, Cats and Fame. Now, in order to perform at the theater, the Cats musical company must pay a royalty fee of $1,250 plus $325 per performance to the theater. The same theater is also hosting the musical Fame. The musical company of Fame has to pay a royalty fee of $1,400 plus $250 per performance to the theater. Before we go on any further, we want to label and identify what is our fixed cost and what is our variable cost. So Our royalty fee of $1,250 for cats would be our fixed cost for cats, and then the $325 would be our variable cost for cats. Now, our $1,400 would be our royalty fee or our fixed cost for Fame, and then the $250 per performance, that would be our variable cost. So we want to create equations for both musicals. So we let C represent the total cost that the musical must pay, and we'll let N represent the number of shows that the musical will perform. So we have our variable cost and our fixed costs for both musicals, and this gives us an equation of C equals 325N plus 1250 for cats, and then Fame will cost us $250 per performance plus a fixed cost of $1,400. Now we want to create a table of values for both musicals. So we start off by identifying our y-intercept, which is B. As you can tell, the y-intercept is 0 and 1250, and then 0 and 1400 for cats and Fame, respectively. So for cats, we're going to increase the cost per performance by 325. And then for Fame, we're going to increase the cost by 250 per performance. So that gives us this table. Now I want you to notice something very unique. Over here, there is a point of intersection at 2 and 1900, and we're going to see what this means in a second. So we want to graph the musicals on the same grid. So as you can tell here, for cats, we start off at 1250, like we do over here, and then for Fame, we start at 1400. Now, for under 2 shows, cats is going to be more affordable than Fame. But if the musicals want to perform more than 2 shows, and I imagine they would, then Fame is going to be less expensive than cats. Fame is going to be more affordable. Now notice over here that we still have our point of intersection, which is 219. As you can tell, both lines cross at this point. Now, at how many performances will both musicals pay the same amount? Well, the point at which they pay the same amount is the point of intersection. So, after 2 performances, both musicals will have paid the same amount of $1,900. Now Manny is running a race at a constant rate. He records his distance from the starting line at various times as shown below. We want to complete the table for this linear relationship. So as you can tell, some rows are missing in the table. Slope must be constant, and keep in mind that delta y and delta x from one row to the next is not necessarily the same for every row. So what does that mean? So we go from 0.5 plus 0.5 gives us 1. 1 plus 0.5 equals 1.5. 1.5 plus 0.5 gives us 2. However, 2 plus 0.5 does not equal 3, and 3 plus 0.5 does not equal 5. So, all those numbers to say is that x is not evenly spaced. However, this does not stop us from finding out the missing values. So, in order to find those missing values, we need to first calculate the slope. So we have that our delta y and delta x over here is 3.5 and 0.5. So what does this mean for us? Well, that means that for every hour spent running, he will run 7 kilometers. So let me say that again. For every hour that Manny spends running, he'll travel 7 kilometers. So since our x, or in this case our t, is spaced by intervals of 0.5 at the beginning here, that means that for every half hour or 0.5 hours, Manny will travel half of that, which is 3.5 kilometers. So we want to start by stating, okay, so it's going to go up by 3.5 kilometers after each interval of 0.5. Now we want to first find the y-intercept, because the y-intercept can give us a lot of information. So to get from 0.5 to 0, we'll just have to subtract 0.5. And if we're going back 0.5, then we're going to be going back 3.5 kilometers as well. So that leads us with 0, 0. Now this is the origin. This is a very good point for us because now we can tell right away that this is a direct variation. More on that later. And then we can start filling in all the values. So 3.5 plus 3.5 equals 7. Now, how can we figure out what this is? Well, the change in x is 1, right? So the change in x is 1. So then if we just put 1 instead of x and m equals 7, so our change in y is going to be 7 equals 7 equals delta y over 1. So delta y equals 7. And so that means that if we're traveling 1 hour, we're going to travel 7 kilometers. And if we travel 2 hours, which he did here, then he's going to run 7 times 2 kilometers, which is 14, which is what we have here. Now, we want to create an equation to represent Manny's running speed. Now remember, we want to define our variables. So let d be his distance and let t be his time. So we let d be his distance and t his time. And notice how at the table, it was at the origin, so there is no b value. So that means that we'll just have d equals 7t, where every hour he'll run 7 kilometers. Now we want to graph this relationship on the grid, and we have this. Notice how it does indeed start at the origin, 0, 0. Now, to consolidate and to summarize all of this, the first differences in the pattern in x values can be used to find the slope of a linear relation. Okay, so that means that if we have our first differences and the pattern in x values, we can find out the constant of variation. So we can see what changes with every additional unit of x. The constant of variation is also the slope of a linear relation. Now a constant, or average, rate of change can be interpreted as the slope of a relation. So that means that on average, Manny was running 7 kilometers an hour on average from when he started running to 6 hours after he started running. On average, his average speed was 7 kilometers an hour. Now slope can be symbolized as m equals delta y or delta x, where we remember where delta represents the change in. Delta is a Greek letter. In this case then, that means the change in y is the y value of the second y value minus the first y value divided by the second x value minus the first x value. This is the same thing as saying the rise over the run. And now a line has an equation of the form y equals mx plus b, where m represents the slope and b represents the vertical intercept.